In this video we analyze infinite sets where the elements are equally spaced. And so we need to lay some groundwork here with some language and notation that we will use. The first thing I want to understand is how we're going to use this variable n. And the way we use this variable n is it's going to be a representative of the number or the position of an element in an infinite set. Let's look at an example of how we use this n number. So here's an example of an infinite set where the elements are equally spaced. And what I mean by that is from 2 to 4 is 2 units, and from 4 to 6 is 2 units, 6 to 8 is 2 units, and you can see there's an equal spacing of 2 amongst those elements. If I want to know which element corresponds to n equals 4, what that means is I'm looking for the fourth element. And that's exactly what I mean by position. So I just count 1, 2, 3, the fourth element is 8. It's the fourth element, or you could say it's where n equals 4. So n characterizes the position of an element in a set. Let's ask another question in relation to this set. Determine n for the element 12. So I need to know the position of 12. So that's 1, 2, 3, 4, 5. It's the sixth position. The sixth element. So n equals 6. So hopefully you have an understanding of what n represents now in these infinite sets. Let's do another example that's a little harder. I'm going to describe the elements of the set, and then I want you to come up with the set. So I want you to write this infinite set where the nth element equals 3n. So here we have a formula to calculate the elements. And so if I want to know the first element, then that means n equals 1, which means that the nth element, or sorry, the first element is 3n, 3 times n, or 3 times 1 in this case, because n is 1. So the first element is the number 3. The second element is when n equals 2. So I take 3 times 2, and I can see that my second element is 6. My third element is when n equals 3, so I multiply 3 by 3, and I get 9. And you can start to see you're simply going to get the multiples of 3. So 3, 6, 9, 12. There's an established pattern, so I can do my dot, dot, dot. And to be even better, what we can do then is we can write the general term, which is represented by the formula. So we dot, 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 do the ellipses, and we can say, well, a general term looks like 3 times your n value, comma, dot, 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 to finish the infinite set. And so that's the formula for this set. It tells you how to calculate every single element, and that's really what we're building up to here, is how do we determine that sort of formula. Now, another observation about this particular set is they're evenly spaced elements. You add 3 over and over and over again to get the elements. And that's why eventually the general formula is multiplication by 3, because you're taking and you're adding 3 multiple times, which is the same thing as multiplying increasing numbers by 3. So that's the key here, that even spacing gives you this multiplication property. The even spacing between the elements gives us the multiplication formula. And that's going to be important for us to understand as we move forward. Okay? Let's do an example that's a bit harder. Now I'm giving you the set, and I want you to tell me a formula for the nth element. And so what we notice here is we need to observe the spacing. The spacing is +7 each time, etc. So that means I'm going to be looking at something like 7 times n as my formula for my nth element. So what we're going to do is see if that is the formula. So we can see, according to this formula, if n equals 1, then the first term, or first element, according to that formula, should equal 7 times n, but n is 1. So 7 times 1 should be 7. And in fact, the first element is 7 in this set. Let's check the fourth element, for example. If n equals 4, then according to this formula, our fourth element should be 7 times our n value of 4, so 7 times 4, which is 28. And our fourth element is 1, 2, 3, 4. The fourth element is 28. So this is the formula for the nth term. So what that means is we could actually rewrite our set. So rewriting the set using, or let's say including the formula, we get 7, 14, 21, 28, ... 7n as the nth term, ... And so this is a better way to describe the set than what we had up here, because now we can see, well, if I want to know the 1,000th term, I just take 7 times 1,000, and my 1,000th term will be 7,000. So this gives me a way of predicting all of any element in the set that I want to. Let's try another one. I want to find the formula for the nth element of this set. In the elements here, I'm subtracting 4 each time. So that means that my formula is going to be like a -4n. -4 times n. And we can check again. If I plug in 1 for my first element, so for n equals 1, my first element should be -4 times 1, which is -4. And in fact, my first element is -4. And you can start to guess. If you want to know the third element, -4 times 3 is -12, and you will get the third element, -12. So we've got our formula here. And if I want to rewrite my set, I would have -4, -8, -12, maybe -16, ... And then the nth term would be -4 times n, and then the remaining terms after that. Okay, so I like this way of rewriting the set, including the general nth term. Okay, let's do another example that's a bit more difficult. So in this set, we've got an even spacing of +5, etc., which means that we should consider the formula 5 times n. But for our first element, according to that formula, we would say n equals 1, which means that the first element would be 5 times 1, which is 5. And the first element should be 5, but it's 1. It's not quite correct. Okay? So this is the incorrect formula, and we can see that here. But the spacing is still by 5s. So what we can do is we can adjust our formula. 1 is not 5. Right? 1 is not 5. So the formula 5n gives us 5 as a first term. So how can I adjust it? If I subtract from this, if I've got a 5 as my first term and I need it to be a 1, let's subtract 5. Or sorry, let's subtract 4 so that we get the correct first term. So the idea here is that the first term we actually get from our formula is 5, and I need it to be 1. But if I take 4 away from 5, I'll get 1. So let's propose a new formula. How about 5n? So it's very similar to 5n. The reason we use that is because we have a spacing of 5. But I need to adjust it so that my first term is correct, so I'll subtract 4. Because the first term again of this would give me a 5, and I need it to be a 1. And if I subtract 4, I do get 1. So let's check it. If n equals 1, then our first element, according to this formula, will be 5 times n, which is 1 for the first element, minus 4. 5 times 1 is 5, minus 4 is 1. And there we go. We've got the correct first element now. Let's randomly check a different element, like the fourth element. Our fourth element should be 16, so let's see if it's correct. I'll plug in 4 to this formula, so I get 5 times 4 minus 4, which is 20 minus 4, which is 16. Lo and behold, we do get the correct fourth term. And the reason for that is this set is very similar to the 5n set. So let me show you. Okay, so this is the correct formula. I can rewrite this set now using the nth term formula that we just found. So 1, 6, 11, 16, 21, dot, 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 the nth term, 5n minus 4, comma, dot, dot, dot. So here's how to think about this. The 5n set looks like this. It's spaced by 5, but it also starts with 5. So look at this. The 5n set is here, and this one's very similar because they are both spaced by 5s. So if I want to turn my red 5n set into this blue 5 spaced set also, all I have to do is subtract 4 from each term. 5 minus 4 is 1, 10 minus 4 is 6, 15 minus 4 is 11. And that's exactly what we're doing. We're taking our 5n set and we're subtracting 4 so that we adjust this set to give us the set we want. Alright, so the key is observe the spacing of your elements. That's going to give you this generic formula, and then you adjust by adding or subtracting to make sure you get the correct first term. So I'll state that down here. Determine the spacing of the elements. Use that to get the multiplication pattern. Then add or subtract as necessary to adjust the first term, thus correcting all the following terms. So I think it's good to sort of summarize what we've done here. I've tried to show it very thoroughly, but that's exactly what we're doing in this process. Okay, I hope you learned something. I hope you enjoyed this explanation. I think it's a really interesting concept and pretty neat. So enjoy.